NCBM 0324, Section 1.1, Order of Operations, Part 5. Now in the previous examples, and we did quite a few of them, so we got some good experience with the order of operations, but in each of those, I kept saying we're simplifying the expression, right? Something that's often confused is the idea of an expression versus an equation. And they are related, but they're also different. So you want to make sure we can distinguish between the two. So a few vocabulary terms to get us more familiar with the differences. The first one here, we're going to say that a variable is a letter or symbol representing an unknown quantity. Oftentimes we see the letter X, Y, Z, but we could really use any letter or symbol to represent this unknown value that I'm trying to find. Our second definition, we're going to say an expression is a collection of numbers, variables, operations, and grouping symbols. So this is where we start to combine a lot of what we've seen so far. So an expression can be made up of a lot of numbers, like we worked with those operations and those grouping symbols, meaning parentheses or the square brackets. So this is where we start to mix things up, right? And then the numbers, I don't know, maybe 1, 2, 3. But now we're also saying that we can include variables. So maybe X and Y, maybe A, B, whatever variables we're talking about here. But the key thing to an expression, it's just a collection of these items, right? We're oftentimes asked to simplify an expression. And that simplifying means that there's some sort of nicer way of writing it, right? We can reduce some of these operations, maybe get rid of some of these grouping symbols to get something more useful, you might say. The third definition, we're going to say an equation is a number sentence that states that the expression on either side of the equal sign, in fact, I'm going to highlight that, equal sign represents the same number. So while an equation is made up of numbers, variables, operations, grouping symbols, the difference now between an equation and an expression is that I have this equal sign. And that equal sign is telling me that either side of that symbol represents the same number. It represents the same value here. So an expression is just a collection of these objects. An equation has a left and a right-hand side with that equal sign in between. Expressions we're asked to simplify. Equations we're often asked to solve, right? We cannot solve an expression, but we can solve an equation, right? Solving an equation means you're finding an actual value. You're using that equal sign, that balance of the left and right-hand side being the same number to solve for some value here. So in example 2, identify the problem below as an expression or an equation. So looking at part A, I have parentheses 2 cubed plus 4, close parentheses, divided by 3. All of this divided by, open parentheses, 8 plus 2, close parentheses, divided by 5. So looking at those values, I have numbers, a lot of operations. I have some grouping symbols. Those parentheses are in my numerator denominator. You know, I have a power, I have addition, I have a lot of divisions, in fact, 3 of them. But what don't I have in this example here? I don't have that equal sign. So there's no equal, something else on this side. So when there's no equal sign, I'm going to say this is an expression. So then we would be asked to simplify this expression, right? Make it nicer, make it a smaller value that we can really work with here. What about B? we have negative 7x minus 10 plus 9x minus 4 minus 5x. So I have an introduction of a variable. My variable here is x. I have x in 3 different places, but I also have my regular operations. I have numbers in here as well. The minus 10 and the minus 4 are just regular old numbers. Again, what don't we have though? We don't have an equal sign. So this one is in fact an expression. Last one, C. We have h plus 4 is equal to 5. H plus 4 is equal to 5. So even reading it, I can kind of start to see my answer here. The fact that I'm saying equal to a number, right, equal to something on the other side, is going to tell me that this is in fact an equation. And then we would be asked probably to solve the equation. So this is telling me that equal sign is this left-hand side has to be the same number as the right-hand side. Then we will be able to figure out the h value that would make that true. But that's in fact an equation. So it's important when we're asked to solve something, right? We're given an equation. We'll learn about solving equations in our next section, but that's different than being asked to simplify an expression. Let's simplify something with some variables in it. Let's look at example 3. On part A, we have negative 7x minus 10 plus 9x minus 4 minus 5x. So if you notice, this is the same problem from example 2b, but now we're asked to simplify it. So in the simplification with variables, we want to still follow our order of operations. So we're going to look at PEMDAS still, but we also want to consider what we're able to combine. So when we say something like combine like terms, we're saying we can only add or subtract things that look the same. So in this case, what parts of my expression look the same? Well, this negative 7x, this plus 9x, and this minus 5x all have an x attached to them. So that's why I'm going to combine those like terms. They both have just x by themselves. There's no powers to them, right? There's not x squared, x to the third. It's just an x value by itself, and that's what we call like terms. The other like terms we can talk about are the numbers, right? The negative 10, the minus 4. Those are only values. They have no variable to them. So I'm going to be able to combine those pieces. So if I combine my x values first, let's do that. We'll do the negative 7x plus the 9x. That'll give us a nice positive 2x. We'll keep everything else and work our way forward. I still have some like terms with the x values. So I have 2x now minus 5x. And that'll give me a negative 3x. Minus 10 minus 4, so I've combined my like terms, adding my values now, my numbers that don't have a variable, those are like terms in themselves. I'm going to get negative 3x minus 14 as my answer. And there it is. Now, this is where we want to make sure we know the difference, right? We've simplified. Is there anything else we can do with this minus 3x, this minus 14? There's really not, right? I cannot combine the negative 3 with the 14 because the 14 doesn't have an x, and the negative 3x does have an x. So they're not the same type of piece of term for our expression, and that's as far as we can go. The other thing is, can I get to some answer? Can I keep going and eventually get x is equal to, I don't know, 3? I'm just kind of throwing a number out there. Well, I can't because I don't have another side to my equal sign. This is just following upwards, and my starting left side of my equal sign has a bunch of variables and everything in it. So there's no value on the other side of that equal that I would be able to use to solve for that variable x. There's no number on the other side. Our answer, this is as far as we can go, has a variable and a constant part. So watch for that. It's tempting to just want to solve for everything, but really in this one we can't, because there is nothing to compare it to on the left side, right, in this case. Let's try this example 4 down here. Example 4. What is the value of the expression 10 minus x plus y divided by 2 when x equals 5 and y equals 2? So they're telling us right off the bat, we have an expression. So we don't have an equal sign on the other side. We're not solving for anything. We are trying to find the value. So we're evaluating. We're going to simplify what they give us here. So I'm going to have my expression 10 minus x plus y divided by 2. And they're asking us when x is equal to 5 and y is equal to 2. So when they give us specific values to use for our variables, we're going to take those values and we're going to plug them in. So I'm going to plug in the 5 and I'm going to plug in the 2 for the y. That's going to give me another expression, but now there's my 5, there's my y, my 2. Now all I have are values. So it looks more like what we started the section with, right? We're just evaluating this. So PEMDAS, one more time. I don't have any parentheses. I don't have any exponents. I do have a division. There's no multiplication, but I have the division. So I'm going to do that first. That's going to give me 10 minus 5 plus 1. Right, there's my division. 2 divided by 2 is 1. Then I'll go with my addition subtraction, always from left to right. So I'm going to do first the 10 minus 5. Well, that's 5. Plus the 1 gives me a 6. And there's my answer. So again, so important that we practice word of operations, because just about every calculation we make in our 1324 class is going to involve in some way some order of operations. So the more experience we get with it, the more connections we make to it, the easier the problems will seem in the long run.